All right, advent of code, day 22. Here we go. Okay, I think it should be separated by what, 2 lines, 2 new lines. Yeah, okay. Okay, so now we've got the grid in there. We wrap around to the other side of the board. Opposite of your current facing. Oh, that's a weird shaped board. Is it like a cube or something? It doesn't really matter. So basically, if you're at A and facing the right, tile in front of you is marked B. Okay, sure. That makes sense. So what we want to do we even care about efficiency on that? Maybe, maybe not. Okay, well anyways, we have the path. The number is a number. Okay, cool. So it's fine. This is a great case for tools.groupby. This is going to be instructions, and this is going to be like this digit. And what we'll do I think that should work. Cool. In the path. Yep, nice. And what we'll do is, okay, so our current position is going to be what? The first empty tile. So what are these? Are these block tiles? Like if we walk into them, we stop. Also, how long is the path? 4,000? Okay, this is gonna be a little slow. That's fine. You cannot enter. Okay, sure. And I assume if you can't enter it, you just stop. That's fine. So we're gonna start at four. Is it weird? Yeah, it is weird. Okay. Okay. Wow. We're not at an empty cell. Cool. And that puts us in an empty cell. And we're facing to the right. So, in terms of these directions, that would be +1 in the y direction. That's going to be 0. 0 integers. And turning right is going to go plus. Plus there. Cool. That's just index integers. And what we do now is it's either right or left, right? Then otherwise it's a number. we do is we're going to do cx equals y, there's under. But now we need to check if we're off the board. Check if off the board. Or blocked. So if the grid at cx_cy is this, well, now we're blocked. We just know that we need to go back a step and break. Like, we can't move any further. If it's empty, then now we need to sort of loop back around. So I believe the way that we do this is, I don't, wait, yeah, if we, okay. I think we can just go in the opposite direction as long as we can. Seems reasonable. This is going to be really slow. But what we can do, we can cx minus dx dy while g of nx and y is not equal to empty. We are going to go in the opposite direction until we reach another corner. And this should be fine. Whoops. This should be fine because the way that this is shaped, I think. Let me just double check. Yeah, I think anywhere that we walk off here, we can just walk in the opposite direction until we hit. Okay, so once we see this blank ground, now we know that the new x and y, the new x, I think, so we're in the opposite direction, so let's add one again, plus dx, oh. So once again, we need to check if, yeah, so the new x and new y are going to be, so we've sort of walked off the edge here. So I think we now need to go not quite off the edge. If there's a rock here, like a solid, then we are going to still do this. Like, we can't wrap around if there's a rock. And it's important we break for efficiency reasons. If there's not a rock, then we just do this. Cool, and I think that's fine. And I think that just works. So now, final row, column, and facing. Rows start one at the top, and okay, so this is fine. I think I just run this. That seems wrong. Let's do, wait. Yeah. So where are we starting at? Okay, so we're basically never updating our y coordinate. That seems a little bit wrong. We're doing dx dy everywhere, right? There's under. I have a bug. You hate to see it. Okay. So what's happening here? Changing the direction. That's fine. Wait, so the x is changing, the y is not? Are we just stuck hitting a rock? If we're at 8-0. Wait, also, I feel like we definitely should not start at 0-0. That was a mistake. Oh, that's a bug. Okay, cool. It's doing something now. Let's get rid of the prints and go again. Okay, so then we have something. Final row column. Ugh, still doesn't look right. The fact that the column's not changing. Oh wait, what? Wait, that seems wrong. Hang on. 0, 0 should be. Oh, it's because I'm stripping. Ah, I don't want to do this actually. Okay, so I think what we now want to do. So that's good. Okay, there we go. Okay, it's actually doing something. It seems kind of slow, but maybe that's ideal. It might be stuck in like an infinite loop. Okay, something is happening. Let's see. Whoa, geez, massive. Okay, well, let's not do this. Or let's immediately start. Okay, so on the very first, it's not equal to a space. Okay, so 50, 0 should be fine. Wait, what? Oh, did I mess my directions? Crap, that sucks. J is the index into there. I is the row. We start in row 0. Wait, yeah, I'm confused. Why is J... Why is I the one increasing? I, J, and then... Oh, no. Oh, silly bug yet again. No. The bugs keep hitting me. Okay, that's doing a thing. Let's kill that. Okay, it's going through the path. Okay, that's good. It'll be faster. CX. CY. Okay, those are numbers that seem kind of sane. And then the direction is 0. It seems a little bit unusual, but that's fine. Rows start from 1 at the top and count downwards. Okay, I think I is our row. Columns start from 1 at the left and count rightward. There's an empty space with no tile on it in the top. Wait, what? Final row. Is there negatives? Oh, sorry. Empty space with no tile on it. Got it. Cool. That's good. So I think we need to do is the sum of 1,000 times the row. So that's CX plus 1 plus 4 times the column. That's CY plus 1. And then plus 0 for right, 1 for down. Okay, so what direction are we? We're 0 right now, which is facing right. So it's going to be 0 for right. Okay, let's try this. Rank 25. Input device. Oh, you'll be able to, it is a cube. Oh, crazy. Why am I not surprised? The wrapping rules are different. You instead proceed around the cube. Oh. That basically means the problems are here. It's a bit of a pain point. Okay, let's copy all this and obliterate everything below. Okay, so now what do we need to do? Yeah, so let's just like jot out what this looks like. So it looks like 1, 2, 3. Is that right? Yeah, 1, 2, 3. Oh, whoops, other way around. 1, 2, 3. 4, 5, 6. Yeah, that seems right. That is a, oh wait, no. 4, sorry, I think 5 and 6 are up here. Okay, how do we do this? So first let's like do some way of checking what region we're in. Well, I do care about the size of the coordinates. Okay, so if I see like coordinate down here, let's look at the max chords. So the max x is 200, the max y is 150. This is exclusive because it's a default if I'm doing some stuff. Yeah, so it's 50 by 50, 50 by 50 cells. So let's do like, so we can find the region that we're in by basically doing this. And what we can do, that would be bad. So let's see, this is 0, 0. This shouldn't be possible. If we're at, let's see, does the region actually matter? Yeah, let's just do this. I think this is going to be easy, maybe. Maybe. No, let's do this. So we can just get the next cell. We'll just write something that does this. And what we'll do is we'll say, okay, so if emder is 0, that's +1 in the y direction. So that's going like right. My x and y are kind of flipped. It doesn't really matter though as long as I'm careful. So let's see. Visualizing a cube is hard. I really want to make sure I don't mess this up. So 1, 2, 3. So let's just like fold this. 3, 2, and I think 1. 1 should touch 3. Is that right? That seems right. And then 3 will be or 4 will be past the 3. So 4 is like behind there. And then 5 will be on the bottom. And then the 6 is going to be on this side. Okay, so I think this helps. So if we're moving to the right, there's 4 places we can fall off, right? We can either be in region 6, region 4, or region 3, right? I actually do want this function, that's what's right. I can't make up my mind. Okay, so 0, 1 is 5. 0, 2 is region 6. 1, 1 is 4. It would be 2, 1 is 3. 0, 2 is 2. 0, 3 is 1. And the max x was 200 and the max y was 150. Yes, okay, sweet. Just, that was just a sanity check. Neat. So now, if we're facing right, if region is in 1, 3, 4, 6, handle, let's do region cx, cy. If it's 1, this is going to be a lot of special casing. I wish there was a better way to do this. I think this is probably the fastest way to write this. Okay, so what are the ones we care about? Actually, 1, 3, 4, 6. Don't care about 2. 2 is going to be easy. 4. Anything else? We are just going to do cx plus dx, cy plus dy. Right, but these regions are special because they need to wrap around. So I believe, let's see, if it was if a cube was like 3 dimensions, like 3 by 3 by 3 by 3, then that would mean, see, this should just be like 50. If it were like 3, and we wanted to wrap around to the other side that was like 6, we would need to go back 1, 2, 3, 4, 5. Okay, so subtract 49 is going to be what it's going to be. So if we're on 6 and we're moving, oh no, this doesn't help. Actually, it does help. If we're on 6, we're moving right, we should end up on 5. Right? If we're on 4 and moving right, we should end up on here. I kind of want to keep this, but what we'll do is we'll expand outwards, just so we know where we land. So 5, so if we're on 6, right, and I'm sort of flattening it out in my head. If we're on 6, to the right of us is 5, above us is 4. Oh wait, if we go above on 6, then we end up on the right edge of 4. Oh, that is not going to be fun to write. Oh, maybe I should have put a z dimension on this. No, I don't think that'd be easy. I think that would be really annoying. I don't think this is going to help. That's going to confuse me. I will just hard code every single case, and we will be like exceedingly careful with this. So we're going right off of the edge of 1. We should end up on 6. And where on 1 we end up on, like on the right edge, we should end up on the bottom side of 6. Wait, this doesn't make any sense. Hang on. Do our directions change now? Like, as soon as we wrap, we shouldn't, what happens now? Oh, our perspective is going to change. Ooh. Okay. So, our direction must now change. Oh man, that's not fun. So, next is now going to return the next coordinates and the next direction. So if we don't wrap around, our direction doesn't change. If we do wrap around, so if we're in region 1, right, we're currently facing right, then the new location, we care about like how far up here we were. Yes. So we're going to do D is going to be, I wish there's a better way of writing this. I bet there is. I bet I'm going to end up so far down on the leaderboard, but I'm kind of committed. Actually, am I? Maybe it'd make more sense to move the cube relative to us rather than move us on the cube. Because I'm just gonna write a bug doing this. Let me see if anyone solved part 2 yet. No one solved it. I'm gonna keep going with this approach and we'll see how it goes. Okay. So we're on 1. What we care about is like our relative height within the region. So that's going to be our CX, actually. And we're going to subtract out 150. And basically, if we were at the very top, that would be 0. Because that'd be like exactly 150. And this is how far to the right we need to end up here. So our new coordinates are going to be, well, the X now is just going to be 49. Because remember, we land on 6. And the Y is going to be 100. Wait. Yeah, 100, because we're at the beginning of 6. We've skipped past 5. Plus D. And then the new direction, we were going right, now we're going up. So that's going to be 0, 1. Now we're going to be going -1, 0, which is going to be 3. Okay. if we go off the edge of 3 to the right, now we should end up, am I really doing this right? I don't think I am. Maybe we can... I don't think there's a way to, like, reflect. No. Okay, let's be really careful here. Drawing my cube. And I care about the back too. So I can make sure my perspective doesn't get messed up. Okay, and we start by putting 3 on the top. And right above 3 is 4. So let's like orient, like let's make an arrow like here. And we'll orient everything according to this arrow. Okay. So this arrow faces up. Then this back one is 4. The arrow now faces down. Okay, if we go left to 2, then here the arrow faces this way. If we then go down, so backwards, we end up at 1. So that's this one. And the arrow faces the same way as 2. Okay, so that's 1, 2, 3, 4. If we're at 4, we now go up, we'll end up at 5. The arrow faces this way. And then if we're on 5 and we move to our right, wait, what? Oh, right, we're on the bottom. Whoops. Yeah, we end up at 6, that makes sense. And this should still face like up, I think. Okay. So, once again, we're at 1, and we go off the right edge, right? Oh, whoops. The right edge, keep in mind now, is here. Wait, is it? Yeah, we should end up with 3 then. Okay. So we should end up at 3, and specifically should end up at the bottom of 3. Oh, right. The bottom of 3. Okay, so we still care about this, but instead now it's going to be 50, 100, 149, and then this coordinate is going to be 50 plus d, I think. And the new direction, if we're going right, so we were going right, and now we're going up, basically, because we go off this way, but now that's aligned with the up direction in 3. So an up was minus 1, 0. Okay, so this is still 3. Okay, now we're on 3. We go off the right edge. We should end up on 6, right? And we should end up at 6, and we're like facing down. So specifically, you end up on, if we're there, like the right edge of 6 is where we end up. This is such a pain. Okay, so the right edge of 6. The closer we are to the top of 3, right? So D is going to be the how far we are from the top of 3. That's going to be... sorry, I keep getting myself lost in thought. Cx minus 100, and place we end up at. Okay, closer to the top of the 3, closer we end up at to the bottom of 6. So remember, we're ending up on the right edge of 6. Yep. And closer to the top of 3 is the bottom of 6. Okay, so it's going to be our x is going to be question mark, but this is going to be 149. And our x here is going to be, I think, 49 minus d. These are both 49s. That seems questionable. If we were at 0, yeah, this is very questionable. Why? I feel like they should match. Let me think more carefully about this real quick. So I did say that 1. Let's also finish. Let's undo bad arrows that we had. Yeah, so we were on 1, went off the right edge, ended up at the bottom of 3. Makes sense. Our x here was 149, so on the bottom edge. I guess it just comes down to whether we're ending up on like the bottom edge or the top edge of like a region, whether it'll be like a 49 or a 50. And here we're ending up at the if we were, these should always be, I think, maybe that's not true. Whatever. Let's just run with it. Oh man. No, this would be so much easier to write of like rotating the cube, I feel. But what if we actually did like the Z trick? I don't know what the best way to handle cubes is. This is crazy. So how many edges do I have to handle if I do this? 4 edges here, 3 edges there, 3 edges there, and then 4 edges there. I only have to do this like a total of 14 times. That sounds super painful. I'm gonna get it wrong, but let's just do it. Oh, gotta stop being indecisive. Okay, right edge of 6. We went off of the right edge of 3, and we come out on the right edge of 6. Okay? And the closer to the top of 3 we were, the closer to the bottom of 6 we land. So top of 3 is 0 here. So then we should go to 49 minus d. Yep, that looks good. And the direction that we're going now, if we were going right, but now relative to that, we're going left. So I think it just needs to be 2. Okay, we're on 4 now. We're on 4. This is really testing my spatial abilities. We're on 4, and we fall off the right edge. So just recall, if I'm walking there, this is the right edge. I think we also end up on 6. That's the right edge of 4. Wait. We're positioning ourselves on top of that. Yeah, it is. If we're going in like any loop around here, the right edge is like this. Although I guess when we get to 1, it's not the right edge anymore. Okay, whatever. Okay, so the right edge of 4, we end up at the bottom of 6. Okay, and what we care about is where we are relative to 4, so that's going to be minus 50. And the place we end up is going to be... Oh, I could probably reverse these later. Anyways, we end up at the bottom of 6, so when this is 0, when we are at the top of 4. So when we are like right here. When we're at the top of 4, we want to end up at like the leftmost point on 6. Okay, so this is like a sane connection here. I think, yeah, these should, well, maybe not always be same connections. But yeah. Okay, so that means we're going to end up at, well, our x is going to be 49, and our y is going to be 100. That puts us at like this bottom left corner of the 6, plus 1 for each number in D. So it's D. And the new direction we're facing now is going to be, let's see, we went right off of 4. So now I think we're just going up relative to 6. Is that right? Yes, I think that is. So, and recall that up is 0, 1, 2, 3. I'm gonna write these. Right, down, left. Okay, so up is going to be, whoops, let's just add some numbers. 0, 1, 2, 3. Up is 3. I'm a little bit curious that we have 2 3s, but I think that makes sense. And if we're at 6, and we go off the right edge, we should end up at 3. Let's see. Does that make sense? We should end up on the right edge of 3. Yeah, if we go off the right edge of 3, we end up at the right edge of 6. If we go off the right edge of 6, we end up at the right edge of 3. That is perfectly sensible. Yeah. Okay. So we care about where we are on the right edge of 6. That's just going to be our x. We don't need to subtract anything. The place we end up in. We really just need to make sure that this is like consistent, that these maps to the same location. So, actually no, I think I need to think about it. Okay, on the right edge of 6, the closer to the bottom we are, the closer to the top of 3 we end up. Cool. So, closer to the top of 6 maps to bottom right of 3. So that's, I think it's going to be, for the x coordinate, it should be 150 minus, or sorry, 149, because we're in here, minus this. 149 minus D. And then the y coordinate is just going to be, we're on the right edge, so it should be 99. Right edge of 3. So we went off the 4. Let's get rid of these. Change to red now. When we went off the right edge of 4, we ended up on 6. We did? Yeah, we did. We ended up on the bottom of 6. And when we went off the right edge of 1, we ended up at the bottom of 6. Of 3, bottom of 3. Cool. That's 1 down. If our direction is 1, right? So that means that we're going down, right? 1, 3, and 6 are the interesting cases here. Otherwise, nothing changes. Cx plus dx, cy plus dy, and then our direction doesn't change. But if we go down off of 1, so that means we're going the opposite direction of 1, we should end up at the top of 6. That feels very straightforward to me. So let's see. Down off of 1, so we care D is going to be Cx minus 150. Why do I always care about Cx? No, I don't care about Cx here. I care about Cy. I should be, yeah, so I should be only caring about Cx in here and only Cy in these cases. So I care about, I think it's just Cy. And let's see, and it's basically gonna just translate directly to here. So we're gonna end up on our x-coordinate will be 0. Oh, I didn't finish this yet. Our x-coordinate will be 0, and our y-coordinate will be 100. 100 puts us here, so 100 plus d. And I don't think our direction actually changes, is that right? We're going down, I mean, like, we end up in something, we're still going down, relatively speaking. So I think it's still 1, which is nice. I gotta revisit this, so we end up at top of 6. Gotta revisit this one. Okay, so we were on 6, and we went right off of 6, and we ended up on the right edge of 3. And in this case, we were going on that side. Right is up. Yeah, so we were going up here. So now we're going left. Straightforward enough. That's just going to be a 2. Cool. Back to this. So we go down off of 3. Down off of 3 takes us into 1. And let's see. So that'll be right of 1. And down off of 3, what we care about is like where we are on this. So that's going to be our cy minus 50. Oops. Where do we end up? Well, if cy was 0, like if we were on the far left edge of 3, we would end up at the top of, we'd end up at the top, or sorry, we'd end up on the right, the top right corner of 1. Yeah, this is one that just like pairs up. So that's easy. End up on the top right corner of 1. So basically, it's going to be, our x is going to be 150. Yeah, 150, and our y is going to be, wait, no. We end up on 1. Yo, sorry, it'll be 150 plus d. And our y will just have to be 49. And we were going down, but now we end up going left. So we end up heading to... Okay, what about 6? If we are on 6 and we go down off of 6, we should end up on 4 is back here. So let's see. Our d. So we'll end up on the right of 4. Going right of 4 did put us on the bottom of 6. So going down from 6 ends us up on the right of 4. That makes perfect sense. And it also means, well, no. Let's just, I'm not going to try and take shortcuts here, which is probably going to be bad. But, okay, so we're on 6, we go down. How far down is going to be cy minus 100, or like where we are, like how far to the left we are. If we're all the way to the left, which means 0, this is all the way to the right, this is all the way to the left. So all the way to the left is here. That puts us on the top right corner of 4. And in general, we're going to end up on the right edge of 4. So to end up on the top right of 4, that would mean it's going to be, our x is going to be 50 plus d, and then 99. And we were going down from 6, but now we're going left on 4. Left is 2. Okay. I'm like not feeling so great about a lot of these. So we're going left now. Now 1, 2, 4, 5 are the interesting cases. This one's going to be rough. One, 2, 4, 5. Otherwise, x plus dx, 0 plus dy. Okay, okay, let's do this. Enter is 2. So right now we're going left. We're going left. We're going left off of 1. What does that mean? It means we went down, we land on 5. We land at the top of 5. Our D is going to be what part of 1 we went left off of. So that's just going to be our CX minus 150. And let's see, if D was 0, we would be at the top corner of 1. And that would put us on the top left corner of 5. So that would be, and we're always going to end up on the top of 5. So our X is going to be 0, and our Y is going to be 50 plus D. 0, 50 plus D. And we were going left, but now we're going down. And down is 1. Okay, we're on 2. If we're on 2 and we go left, we also end up on 5. But now we end up on the left corner of 5. We're going left from 2. This is going to be CX minus 100. Where do we end up? If it's 0, we're at the top corner. And that'll put us at the bottom of 5. So it's going to be 149 minus D. Or sorry, 49 minus D for our X. And our Y is always going to be 50. And the direction, we were going left, but now we're going right. So it should be 0. Okay, we're on 4 now. I'm getting a little faster at these, you know? Probably not fast enough, but faster. We're on 4, and we are going left. So that would be this edge. We're going to end up on 2. We're going to end up on the top of 2. And let's see, D is going to be, we're in 4. Going left off of 4, so it would be CX minus 50. By the way, this just has to be like, if we're going left off of 5, it has to be the X. Or CX. These do kind of follow pattern, even though everything else doesn't. Okay, CX minus 50. So if we're at the top edge of 4, top edge is here, we end up on the left part of 2, the top left of 2. So our X is just going to be D here. Oh, no, sorry. Our X is going to be 100, and our Y is going to be D. 100 and D. 100 and D. And we were going left, but now we're going down. And down is 1. Okay, now we're on 5. Going left off of 5 puts us on the left edge of 2. And the closer we are to the bottom, oh wait, no, sorry. Wait, I'm now wondering if I messed something up on a previous thing. But anyways, we care about the top, right? Oh no. Oh, I just need to run with it. I don't have time to go check anything. What's the leaderboard looking like? No one's gotten it yet? Oh no, they have. I just didn't refresh. Wow, this is some time distributions. I really hope no one else has gotten it the way I did, because this is just painful. Okay. So top of 2, and yeah, I want to look back at this one. So if we were on 4, and we went, so D0 always means, well, not always. D0 here means we're at the top of 4. Top of 4 put us on the left edge of 2. So does D0 correspond to the left edge of 2? If so, it should be like our Y should be 0. Yeah, okay. I handled it right for this one. So we'll just assume I got it right for everything else. Not a good assumption. Okay. Now, back to this. We were on 5. We went left, right? And D here is like 0 is at the top. So at the top, we end up at the bottom of 2. We end up at the bottom left of 2. So that's going to be, x is going to be 149 minus D, and y is 0. 149 minus D, and that's 0. And we were going left, but now we're going right. So it's going to be 0. Okay, last one. And this is going to be up. 2, 5, and 6 are the cases to worry about. Okay, up from 2. See, now I have the arrows. The arrows will just tell me what to do. Up from 2, we end up on the left edge of 4. We're on the left edge of 4. Let's see. So up from 2. Where are we relative to 2? It's going to be, D is going to be just our CY. And where do we end up? Well, when D is 0, that's the top left of 2. Then we end up on the top left of 4. Yeah, that's true. Top left of 4. So that's going to be, let's see, 50-50. Takes us to top left of 4. And then, but it's the y dimension that gets added to because we're on the left edge of 4. So 50-50 plus D. And we were going up, but now we're going right. And right is 0. Okay, so this is 0, 1. This is 3, 2. This is 1, 2. So logically, this should be 0, 3, right? Are there going to be the new directions here? To note for myself. We're on 5. If we go up off of 5, we end up on the left of 1. Up off of 5, it's going to be CY minus 50. And where do we end up? Well, when D is 0, that means we are on the top left of 5. So that's going to be here. We end up on the, wait, sorry, what did I say we end up on? Left of 1. Yeah, that's right, that's right. We end up on the top left. Yeah, the top left of 1. Top left of 1 is going to be at 150, 0. And then 150 plus D, I think. I'm just thinking about something. Okay, done thinking, not important. Okay, so we went left of 1, now we're going down on 5. If we're going down on 5, that's 1. Oh, wait, what? No, oh, no, sorry. We were going up on 5, so now we're going right on 1. And that would be 0. Okay, so far my theory holds up. And let's see, if we go up off of 6, we end up on the bottom of 1, and we're still going up. Okay, cool, that works. Bottom of 1. Okay, up off of 6, and where off of 6 is going to be CY minus 100. Where do we end up? Well, when D is 0, we're on the top left of 6. Top left. So we'll end up on the bottom left of 1. So bottom left of 1. So I think here it's just going to be So bottom left of 1 is located at 199, 199, 0, and then the 0 is just going to become D. So 199, 0 plus D, 199 D. And now we're still facing up. Okay, so we have a thing here. I'll do one quick sanity check, although if it doesn't work, it's not looking great then. So if we're on 1, and we end up going in direction 3. So if we were going in direction 1, which is the opposite direction here, off of 3, we should end up on 1. I'm not going to do this check for everything. I'm just going to punt. Okay, cool. So right turns right, left turns left. That's fine. All great. So the next location, we're not going to do this. What we're going to do now is the new x and new y are going to be next of cx, cy, emder. I don't even need this. And so a few things we could do here. Well, basically we just do if the graph of nx and y is equal to this, we don't move. We're just going to break. Otherwise, cx equals nx, cy equals ny. We just move. I think that's just it. And now we hope we didn't break anything. It should be empty if it's not this. Oh no! I knew it was gonna happen. It means we move somewhere illegal. That is very unfortunate. How far did we get, by the way? Nowhere! We didn't get anywhere. That's so sad. We're just moving 10 in the original direction. And what did that cause us? What kind of pain did that cause us? We shouldn't have gone off the edge there. Because we were just in region... Where did we start? We started at 050, yeah. And this thing claims that 050 going in direction 0, which should, by the way, just add 1, take us to 51. Oh, I just forgot to I forgot to get the new direction. That's my bad. N MD. Cool. And if we do this, then there is an MD. Okay, so we were at CX, CY, and 116, 0. So that should take us to 0 to 50. Okay, so we should be like somewhere along here, right? And we're facing left, and CX, CY, emder. So we're facing left off of region 2 was the problem. Left off of region 2. Emder 2, region 2. Let's double check this. So region 2, so D, in this case, would have been CX minus 100, so it would have been 16. That's all fine. And what? That doesn't seem right. Okay. So that was the cur one. Oh, whoops. And then the new one. Oh, we're getting a none region. That's not good. That is no good. No good. Okay. So this should be 0, 1, 2. It should be 2, 0. Oh no. What is I doing? Okay. X is the first one. 0, 1, 2. 2, 0 should be 2. I did 0, 2. Unfortunate. Let's just check all these. Rx, Ry. So 0, 1 is 5. 0, 2 is 6. 1, this is just obviously wrong. Oh, 1, 1 is 4. Now 2, 0 is 2. 2, 1 is 3. And then 3, 0 is 1. Oh, okay. Okay, cool. And how do we get the answer before? It was like, I care about the emder, though. And then the emder is, right now we're facing right. Is that 2? Oh, wait, what? Or sorry, we're facing left, so that is 2. So it's this, but with a 6. Please. No! Oh. Oh. That's rough. Let's also add like the region that we expect to end up in. And we'll just add this to an assert. This is just to see if we're doing things right. So we'll do like new region. And we'll just assert region of nx and y. This is the new region. Okay. It's a good thing I put comments here. 1, 4, and up in 5, end up in 5, end up in 2, end up in 2. The big problem is going to be if we end up in the right place, but we're like on the wrong edge. That would be bad. And that's maybe the most likely bug. Oh, whoops. I forgot these. If we're in the same place, we'll just end up going to R. Okay, so the new region check failed. When did it fail? 850. And our direction is 3, which I believe is up. Okay, so we're going up from 850. How is that a problem? What? Oh, wait, up? Yeah, that's just -1, 0. We're in region 5. Oh, we only want to warp ourselves if we're actually at the edge. Oh, okay. This is fine. We can do invalid is going to be g of cx plus dx, cy plus dy. If it takes it to empty, then we're in invalid. And now I'm going to do the hackiest thing and just say and invalid for all of these, even though really I should structure this in a better way. That is a silly bug. Oh wait, it's too late. I already did it. It's whatever. Okay. Let's do it. Let's do next of cx cy under. So this one we should warp to a new region. We were at 0, 60. So that means that we were like around here-ish. And we should end up, we're going off the top of 5. And if we recall from our lovely diagram, we should end up on the left of 1. Wait, what? Top of 5. Okay, hang on. Going to the top of 5. Left of, oh, I can't type. Okay, so we were at 7,100, and basically nothing changed. Oh. We'll just do wildcards here. Like, basically the problem is that it's totally fine to cross regions when you're not going off the edge of this, right? Like, you can go from 4 to 3 in like the normal way. So if new region is not 9, then we want to do the check. Okay, this is, but we end up like so close to where we started. It makes me so suspicious. But I mean, we just do it. Mdir is 1. Now I need to actually check this because we haven't seen what whether up should be. Okay, so 1 is down. See, this is right. Yeah. Okay. Nope. Maybe I should be using the sample. And, oh, but I've already hard coded for the 50 by 50. No. That and the shape is just different, right? Like. Oh, where's the bug? Who knows? So here's the thing we can do. We can just assert that, like, walking back and forth, like, we can sanity check our next function by doing the following. So this is like a correctness test, sort of test-ish. It won't catch it if there's 2 bugs that cancel out, which we'll see. But what we can do for x, y in g.keys. And for what we'll do, so we'll do new x, new y, new dir, new region, I guess. I don't care about that actually. Next of x, y, under, cool. And then we'll just go back. From nx and y. We'll just go in the reverse direction. So ender plus 2 mod 4 is the reverse direction. And now assert nx equals nny, or sorry, equals x, and y equals y, and the new direction is now the opposite of our original direction. Something went wrong. Something went wrong. Next should always return 4. Oh no, whoops. It's a little silly, but okay. Is that non-trivial? I don't know if it is or not. Okay, so region of x and y. We're in region 4, allegedly. Let me think about that. Yep, so we're at the top of x. We're at, oh, sorry. We're like just 1 below the top left of 4. 1 below top left of 4. And our direction, let me guess, it's left. No, it's right. Oh no, that is left, that is left. 2 is left. Okay, cool. And if we go from here, if we go left from here, and then we end up in region, we end up at 101, which is region 2, and 101. That seems pretty correct. Maybe the direction is not right. And the direction now should be down, I believe, which it is. So now if we go back up from 101, I mean, either direction could be wrong. Stay calm. If we go up from 101, we should end up at 5150, which we don't. We end up at 5051. And the emder is wrong too. Okay, so let's think about this. We're at 101 and 2, and we go up. Yeah, we should end up on the left region, left part of 4. Which, we do end up in 4, but we end up at like... we end up at the boundary between 4 and 5, which is like clearly wrong. Okay, so emder is 3. Is the bad case. And where we end up on the left of 4. You know, it's probably just this, but I should really think about it. Okay, up from 2, end up at the left edge of 4. That's good still, yep. And if D is 0, then we are ending up at the top. Sorry, if D is 0, we're at like this corner. So that should be like the top left of 4. So top left, it is 50-50, but then it's our X that changes. So it is just this. But then also, now we should be going right. And right is 0. Which, does that make sense? It seems to think it does. I didn't get any errors. It'd be a miracle if that was the only bug. It's too high. Oh! Is leaderboard capped yet? Not quite. So this kind of worked fine, right? Just to be clear, this wasn't affecting my answer. What? It was? Why was it? Oh no, that changed emder? Wait, no, why was it? Zero 50 0. Zero 52? Oh no. That is absolutely silly. And I'm probably locked out for that. Oh! Oh, it worked! It worked! I am actually so shocked that this worked and got me leaderboard. Oh! Oh! Honestly, I'm not even mad about that bug. Like, well, I mean, obviously I'm not happy about it, but like, this correctness testing, this replacing with 2, it didn't hurt me that much, basically, is what I'm trying to say. Oh, wow. Oh, tough question. Just skimming the leaderboard for people I know. But yeah. Let's look at global now. What happened to me? Oh, I fell. Yeah. I mean, I got like... I guess that's not high enough points as I probably needed, but... Whew. Man, that's a tough day. It took me an hour, was that what it was? An hour and 13 minutes. I guess I had like 13 minutes here too. So it took me basically an hour to deal with this cube rotation and to like write this properly. Or to write this and debug it. Because I guess it's more impressive to write it and debug it than it is to, well, sorry, when I say impressive, it should take more time to write and debug than it would take to just write it correctly the first time. But I think I got lucky. I only had like, was there only one bug in here that was actually bad? I don't know how many things, if these region checks caught anything. I don't think they did. But this little correctness, making sure going back and forth gives the right thing, like, that's a pretty strong condition. Basically, what I was trying to do there is, like, it's entirely possible. Like, I was fairly confident after, like, adding the region checks made me pretty confident that, that like, I had the right edge transitions. So if I went off of this edge of 3, I would always end up on 2. But I wasn't so confident that, like, if you went here off of 3, sorry, when I say confident, I mean confident in my code. And, like, there's a possibility my code would spit you out here, right, which is a problem. And I was trying to be careful with this, but this is, like, a really big concern. But notice that if you have this bug, and then you try and go back over the edge, right, like, going this direction, going from 2 off of this edge of 2, is like, it's a different code path, right? So it's entirely possible that this would take you to the right place. And this is like very easy to check. Like if we start here and end up here, like that is a bug. And it's very easy to tell you where the bug is. It must be on either the 3 to 2 transition or the 2 to 3 transition. So that's what this correctness test here was testing for. But now the risk, of course, is that like if I've made the same bug in both places and it cancels out, then you actually will end up on, in quote, the right place, but for like the wrong reason. And I think if you have this mistake in both places, it's really hard to catch with like black box testing. I think you just kind of have to like look at everything. Is that true? Oh, there is a way you can check. You can. Is that true actually? Yeah, I think it is. If you. So I was thinking about this just now as I was like in lockout, which is that like if you try and walk in a square around the edge, again, this is like black box testing, right? So this is not even looking at the internals here. And the reason we're doing that is because the internals here are terrible. If you look at these, you will never find a bug because it's just impossible to read. But if you walk in like a square, like this square pattern, like left, down, right, up, which I think you could just come up with as like 1L, 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 1L. 4 1s, 4 Ls, yep. This should end you up in the same position with the same rotation. And I think if you made this bug, what it would do, so here you would go past, then you would move here, then you would move back. But when you go back, you wouldn't end up here, I think, because like the way that this bug is like mirrored. So you'd end up here actually, like you end up too far, and then you'd go past. So I think if you did that, actually it would be able to catch that kind of bug. Fortunately, I didn't have that kind of bug where I made the mistake on both sides. I only made the mistake on one side. And the mistake was not even that. The mistake was just that, like, I don't remember, was it even the region check failing? Maybe it was. Oh, no, it wasn't the region check failing. That's right. It was, the bug that I actually had was if you went off of this edge on 3, you'd end up on, like, this edge of 2. It wasn't actually 3 and 2. I think it was 4 and 2. But it doesn't really matter. And, like, this is, when I looked at the numbers, this is, like, very obviously wrong. And it was just that I had the wrong coordinate here. So I just needed to, like, flip the X and the Y, and it fixed it. Cool. If I hadn't made that bug, then I still would not have placed very highly on the leaderboard. But yeah. Oh, that is a tough day. All right. Well, I think I will call it here then for day 22.